Fine, I'll admit it's a cheeky title. And I was quite proud of myself for coming up with that. You see, when I say irrefutable proof for flat earthers, grammatically it means I have something for a group of people. I could have equally called it irrefutable proof for globe earth, and that lack of ER at the end would mean I have proof for that concept. So sorry flat earthers if you thought I have something to support your view. Quite the contrary. One of the deal with flat earther is they would deny any photograph from space. Those are all photoshopped, they would shout. Maybe it's the dome that stops us from going up. Maybe NASA and other space agencies like China, India are all in cahoot and are lying to us. We never went to space. Well, I have an experiment for you that maybe you can perform. Let me take you back to the year 1969, 16th of July to be precise. Unfortunately, I wasn't born at that time and missed all the fun. It was an important date for the whole mankind. You see, that's the day Apollo 11 left for Moon, successfully landed on Moon and then back to Earth. It was glorious. If one were to ask, the first thing we all think about is the footprint we left behind. Millions of people have seen pictures of it, and maybe one day, years from now, lunar tourists will flock to the Sea of Tranquility to see it in person. But there was another important thing they left behind. About 100 feet away from that famous footprint lies a 2-foot white panel studded with 100 mirrors pointing at Earth. The Lunar Laser Ranging Retroreflector Array. Apollo 11 astronauts Buzz Aldrin and Neil Armstrong put it there on July 21st, 1969, about an hour before the end of their final moonwalk. So what are retroreflector? Well, it is an optical device that returns an oncoming beam of light back to its source. It can be simply as a tiny glass sphere or a type of a prism formed from glass or plastic. While ordinary flat mirrors also reflect light, the light isn't reflected back to the source, but off to the side at the same angle the beam arrived. Only if the light beam is perfectly perpendicular to the surface of a flat mirror, it will act like a retroreflector. Retroreflectors are so much a part of everyday life. We see it in taillights of vehicles, safety barriers, traffic signs, and so on. So let me make it really simple. We left mirrors on Moon, you shine light, it reflects back. That is kind of it. So let's start with a powerful enough laser device. I know you guys have those. You will also need a detector powerful enough to capture the reflected photons. Then you're all set. Shine a laser at those retroreflectors and wonder at the joy of getting the reflection back. Or you can watch some other people doing the very same test with the very same result. Couple of additional things I would like to say. Before you say it's the reflective nature of Moon, just listen to yourself. If you're not targeting the retroreflectors, but say targeting that footprint, you will not get any photons back. So that reflection only happens in that specific location with a very specific area dimension. Well, the Apollo 15 Lunar Laser Ranging Retroreflector LRRR array is one of the 4 working arrays on the surface of the Moon. This is the largest, being 105 by 65 cm in size, serves as the primary target for laser ranging to the Moon. The Moon's surface is about 38 million square kilometers. Now, as we are only looking at one half, we are seeing about 19 million square kilometers. So listen to the numbers again. Out of 19 million square kilometers, only 6,825 square centimeters does this reflection. Trust me, kilometers is much larger than centimeters.
How do you convert meters into kilometers?
What's the correct way?
You tell me.
The correct way is divide meters by 1,000.
So if you have a meter and I divide that meter by 1000, you don't think that would give you millimeters? So you're saying I divide something that is 1 meter long by 1000 and that will come out to a kilometer value.
Nathan,
It sounds
let's keep
like
on- let's keep on track,
you
let's
are
keep on
quite
track.
literally retarded
Let's
with that
keep on
statement.
track.
The reason that part reflects because we left something there. We left something there when we went there. We went there on a spaceship. When we're in space, we take pictures. Do you guys see how it works? Unless, of course, the moon isn't real or that far away, and between ancient times and now, we managed to sneak this thing up while nobody was watching. I guess not so irrefutable after all. Well, that's all for this video. Thank you for watching. If you have enjoyed it, please like, comment and maybe even subscribe to help this small channel grow. Have a safe day. Signing off.